Okay, welcome to this video where we're going to be having a look at exponentials and logarithms. Now in this particular video we're going to focus on looking at logarithms. So we'll be looking at using logarithms, the laws of logarithms, solving equations using logarithms and working with natural logarithms. So for the other part of the video when you're looking at exponentials, you just need to go into the description and find the link for that. But I'm going to split this video into two parts. So the first part where we're looking at logarithms and the second one we will have a look at exponentials. This is obviously the final chapter of the AS Pure Maths curriculum, so this is going to be the last chapter revision video looking at any of the AS Pure content, and hopefully you've already been through the rest of the chapter revision videos, but just in case you haven't, here is a quick recap on how to use this video. So when you are on one of these videos, if you click into the description, you can see the video there where I cover all of the AS Pure curriculum, and if you scroll down you can also see all of the chapters. Now these will slowly be filling up until it has filled the entire AS Pure curriculum, so hopefully by the time that you are watching this video, all of them will be actually in the description and you can click and watch each chapter. If you click onto the video and click the link in the bottom left there, you can actually see all of the chapters that are within this video as well. So you can skip through and have a look at the pieces of that chapter that you are needing to have a look at for your revision. So that's how this video works. Hopefully that's useful and helpful. If you enjoy this video, please don't forget to like the video, don't forget to share it with some of your friends. But with that being said, let's get started. So something like this, 2 to the power of x equals 8. This isn't built to be particularly difficult. Hopefully you can spot here that 2 to the power of 3 is equal to 8. Or in other words, 2 times 2 times 2. And we could write that. We could write 2 to the power of 3 is equal to 8. Now when it comes to logarithms, there is another way of writing this. Now just like when we're looking at these powers here, we know that this number here, this 2, is called the base number. And that's going to apply when we look at a logarithm. Now what we say for a logarithm, and this is going to mean exactly the same thing, it's just a different way of writing it. We're going to say that log with a base of 2, just like here we've got our base number of 2. What log with a base of 2 gives us the answer 8? So log base 2 of 8. And we might say that equals x or something, or we're trying to find out what that answer is. So what power of 2 gives us the answer 8? And we know that the answer is 3. Okay, we've just worked that out. And that would be the answer there. If we wrote log base 2 of 8, our answer would be 3. So all that this means here is essentially what power of 2, what power of 2 is equal to 8. There we go. And that is really the fundamentals here behind logarithms. And as long as we can understand that concept, we can look at it in all different types of ways. But all we're going to be looking at here is basically what powers of certain numbers equal particular answers and sort of mixing those and sort of rearranging that in certain ways. Now we could write this as a sort of, not as a formula, but we could write this obviously with letters rather than having the numbers here and looking at how obviously we rearrange this. So we could say that log base of, and let's just call it a, with this letter b here, is equal to x. And what that means in terms of a power. And that means that, and again the base of a is our main number here, or in this term obviously writing a letter at the moment, but a to the power of x equals b. And that there is obviously something pretty key to write down, because that's how we're going to be sort of writing these and writing them in sort of different ways as we move through this video. But obviously just thinking about this logically, log base 2 just means the number 2 to the power of something gives us this answer here. Okay, so what power of 2 gives us the answer 8? And that power there is 3. So let's think about a different example before we move on. I could say something like this, obviously rather than writing it as a power, we could say log, and let's go for base 3 this time. So what power of 3 gives us the answer 9? So we'll go log base 3 of 9 equals x. And I might ask you here to find the value of x. So if we've got this little problem in front of us, we would say, okay, well 3 to the power of something, and we've obviously got the letter x there, is equal to 9. So what power of 3 gives us the answer 9? And hopefully that's nice and easy for you to spot. We know that it's 3 squared that equals 9. So we would say x equals 2. Or we could say, you know, log base 3 of 9 equals 2. But that's really the fundamentals here behind what logs mean and how we're going to use them. Okay, so something a little trickier here. We've got find the value of x such that log base 4 of a 1 over 64 is equal to x. Or in other words, what power of 4 gives us 1 over 64? Well, let's write this out. So we have the base of 4. So 4 is our base number. 4 to the power of something, which is our x this time, is equal to 1 over 64. So we know from the last one, again, obviously depending on how comfortable you are with your negative indices, we know that in order for it to be a 1 over as the answer, it's going to have to be a negative power. So we already know part of the power here. We know it's going to be 4 to the power of minus something. And we need to get to 1 over 64. So what power gets us from 4 to 64? Well, we can work that out just down below. Let's have a look. 4 times 4 is 16. And if we times that by 4 again, isn't the nicest one to do in your head, but 16 times 2 is 32. Double that again, we'll times it by 4, and that gets us to 64. So it's 4 times 4 times 4, or in other words, 4 cubed. So it's going to be 4 to the power of minus 3. So there we go. We know 4 to the power of minus 3 gives us 1 over 64. So we could say log base 4 of 1 over 64 is equal to negative 3, the power there. Or in other words, x equals negative 3. And there we go, there's our final answer. So that's all that this means when we're looking at logs, okay? So it's just about looking at the way that the log is written and reading it just like we recognised before. Log base, and then we have our base number. Then it gives us our answer, 1 over 64, is equal to what power, or in other words, what power of 4 gets us 1 over 64. Okay, so as long as you read it like that and sort of understand the way that that writing translates to that wording, you should be absolutely fine working through some of these problems. Okay, so this question here will show you how obviously we can use logarithms to actually solve some of these indices problems. So we've got here, find, giving your answer 3 significant figures, the value of x for which 5 to the power of something equals 10. Now this is quite nice, and this will show you why logarithms are so useful, because we can actually just type these in straight into the calculator, but obviously it does mean that we have to know how to write this power as a logarithm. Now if we write it out, so we're going to have log, there we go, and then we need to put our base number in. So here we've got our base number of 5, so log base 5, and our answer is 10. So what power of 5 gives us 10? Now you can type this straight into your calculator and we'll be able to get our answer straight away. So if you have a look on your calculator, and everyone has different calculators, so you can need to find your button, but there is going to be a button on your calculator. I'm using a Casio ClassWiz, which again I really recommend, and I'll link that in the description, but just underneath the on button or somewhere on your calculator, there's a little button that looks like this, and it normally looks like log, and it has like a little coloured in square and then a little open square. And if you can find that button, you'll be able to do these no problem. So find that button, press that, but get 5 in your little base square and then 10 in your larger open square there, and type that in, and let's have a look. We get the answer, and I get on my calculator 1.430676558, which again, if we give that to 3 significant figures, chop it after the 3, we get 1.43 as our answer. And there we go, it's as easy as that. And you can even test that out if you want. You can press 5 to the power of and then put the answer in, and you will get the answer 10. Obviously if you don't put the rounded answer in, but you put the original one in. So this question says express log 2 or log base 2 of 4 plus log base 2 of 16 as a single logarithm to base 2. And a lot of these links here come to our basic understanding of our laws of indices. And if I talk about this sort of logically, and it will require you to obviously understand what we went over in part 1, but if we look at log base 2 of 4, and we actually calculate that, and that means what power of 2 gives us the answer 4. And if we write that down, let's go for this here. So for this part here, what power of 2 gives us the answer 4? And hopefully we're happy to know that is a power of 2. So let's just give that the answer, x equals 2, if we obviously incorporate that x into our calculation there. For the second part, we've got log base 2 of 16, and again that means what power of 2 gives us 16. Okay, and that power of 2 that gives us 16 is 4, so x equals 4, or the answer's 4. So really what this question is asking us to do, it's asking us to add these two numbers together. So we have 2 plus 4, and let's keep it all in the same colour there. And we know that the answer for that is 6. 2 plus 4 is 6, but obviously it wants it as a single logarithm to base 2. Now in other words, and there is a little quick trick to this, we don't have to do this for every question, you'll see the little trick here, but in other words it wants us to write which log with a base 2 has an answer that's going to come out as 6. So log base 2 of what number is equal to 6? And we can reverse that, okay? So we can think about this as we did in part 1. We can say, okay, well 2 to the power of 6 is going to equal that number that's going to go with our log there. And all we need to do is actually work that out. So 2 times 2 is 4, times 2 is 8, times 2 again is 16, times 2 again is 32, and then times 2 again is 64. So x there equals 64. Or in other words, if we're going to write this log as a single logarithm to base 2, we would write log base 2 of 64. Okay, now let's think about how this links to what we've learnt already looking at laws of indices. Okay, so if we look at these two numbers that were in our logs, 4 and 16, well, there's a link between 4 and 16 and the one that we have now, 64. And that link is essentially, we just have to multiply these numbers together, 4 times 16. And that's going to incorporate our first rule here that we're going to look at with logarithms. Let's just get rid of this little bit on the right here and let's have a look at what we're talking about. So in other words, if we have log, and let's just put base x, and then a number, so let's have it as a for this one, and we add to that another log, and what is key here is it does have to have the same base, and we'll talk about how that links through to our indices as well, with another number, let's call that b. Our resultant log, okay, the log that we're going to get from that is going to be log with the same base, base x, but it'll be a multiplied by b, or ab. So all we actually have to do when we're adding these logs together, so long as they have the same base, and that's absolutely key, we just multiply together those numbers at the end. And if we think about how that links back to some of the algebra that we've done at GCSE level, if we have something like a squared, and we multiply that by a to the power of 4, multiplication being involved there, we add the powers, and we got a to the power of 2 plus 4, which would give us a to the power of 6. And hopefully you can see, look, those little numbers, 2 and 4, link back to our 2 and 4 here, and our 6 and our 6, and it kind of all links together back from what we've learnt on obviously our laws of indices there. Okay, so that's essentially all we're going to do when we're adding logs together. One thing obviously that's very important here, this is when we have the same base number. Just like when we learnt this with our laws of indices, these powers here with our a's can only add together as long as we have the same base letter there, and in this case that was the base letter a. So a to the power of 2 times a to the power of 4, we can add those powers together, but not if we change that base number. And that rule's going to apply with these logs here, and in both of these we had a log base of 2, so we're able to just multiply those numbers to get our final log. Hopefully nice and simple, and obviously you can obviously think about it logically like I did in this first scenario here and working it out like that, but it's much quicker if we have the same base numbers just to multiply those numbers together at the end. So there we go, there is our first rule. This is your key piece of information to make sure you have written down, and that is what we're going to do for adding logs. Now we're going to have a look at taking away, so let's look at that one now. Okay, so you're going to see a lot of links between obviously what we've just looked at and this one here, except this time we are taking logs away. Now again, something to note, we have the same base number. In this case, they are log base 3s, and there's going to be a lot of links back to that process that we've done with our powers of indices again. Now, if you think about, again, just thinking about our laws of indices, if we have something like, and let's go with a to the power of 4, and we divide that by a to the power of 1, what do you actually do with the powers? Well, not forgetting obviously that we have that power of 1 in there, even though it's not written, but when we've done this before, we would subtract those powers, and that would come out as a to the power of 3. Now, if this is something that slipped your mind, these laws of indices, I'll make sure I'll link the video for that in the description so you can check that one out and make sure that you're sort of clued up on your laws of indices there, but that sort of idea there is going to link through. The powers in this case were subtracted, and that was when we were doing a division. This time here in our logs, we are subtracting those logs, and you might be able to guess that we're going to end up dividing these numbers, 81 divided by 3, the opposite of what we just did. But let's have a look at how that works with our logical approach. So log base 3 of 81, that means what power of 3? gives us the answer 81. And that's going to be 3 to the power of 4. So in this case, x equals 4, or the answer to that log is 4. For our second log there, we've got, and this is always an interesting little log as well, we've got 3 to the power of something equals 3. So log base 3 of 3 is 1, and that little relationship there is going to apply to any log. If we have log base 4 of 4, that's going to be 1, log base 5 of 5. Any log base that has the same number after it, our power there or our answer there is always going to be 1. So we've got our two numbers, we've got 4 and 1, and it's as simple as 4 take away 1, and that would give us our final answer, which for this one comes out as 3. And obviously we're not trying to work out that answer there, we're trying to know as a single logarithm to base 3. And if we think about that, we are trying to work out, therefore, that which log with a base of 3, okay, what's the answer if the power is 3? And that means what base of 3, okay, with a power of 3 equals x, there we go. Or in other words, 3 to the power of 3 equals that x value there. So we know that 3 cubed is equal to 27. And there we go, that's the number that needs to go with our log. So if we write that out as a single log to the base of 3, we have log base 3 of 27 is going to be our final answer. And let's just have a look at how that all links through. So again, thinking about those original numbers, we had 81 and 3. And 81 divided by 3 is 27. So it follows that kind of idea that we were talking about just here when we were dividing with powers, looking at our laws of indices, and we ended up subtracting them. It's kind of like the opposite of that. When we're subtracting our logs, we can divide those numbers at the end of the log. So log base 3 of 27. So hopefully that's okay. It's just the opposite of when we were adding. Okay, but I just wanted to show you there the logical way of why it works, and obviously the link between that and our laws of indices that we've looked at previously. So again, two little notes. One is the logs have to be the same base. When we're adding, we can times the numbers at the end. When we're subtracting, we can divide the numbers at the end. But just making sure that we write this down and thinking about this for any kind of logs here, as long as we have log, and I'm going to use the same letters here, base x of a, and we take away log with the same base, so base x of b, our resultant log there, we get log base x of a over b. I'm going to put that a over b there in a bracket. So there we go, that is adding and subtracting logs. We've got one more thing to have a look at before we look at our final questions here, so let's have a look at that one now. So for our final little rule on logarithms, we're going to look at something like this. And it says express 2 log base 2 of 8 as a single logarithm to base 2. And this links nicely into one of our other little rules of indices that we've looked at in the past. And if we think about something like this, where we've had a, and let's just go for a cubed to the power of 2, and we have something like that, what is it we do with the powers? Well, hopefully we remember we multiply the powers. So something like that, we would do a to the power of 3 times 2. Which would end up resulting in a to the power of 6. Now this is obviously when we multiply the powers, and it's when we have sort of a power to another power in the bracket, just like that. And that's going to link through quite nicely to this. Now this is at the moment is not a single logarithm, because what we have here is 2 lots of log base 2 of 8. Okay, we've got this little 2 at the start. Or in other words, we're multiplying that by 2. And what we can do is we can manipulate this logarithm, we can write it in a slightly different way, and I'll show you why it works. So at the moment, we've obviously got it written as 2 log base 2 of 8. Now all we do is we can take this number at the start, this number 2 here, and we can put it as a power at the end of the logarithm. Or in other words, I'm just going to write it here, we can say that it's also equal to log base 2 of 8 squared. And we know that's obviously we can write that as an actual number, we can write that out, and we'll write that out in a second, but we're going to have a look at why this works at the moment. Obviously 8 squared is 64, but we'll have a look at that just now. Now if we look at this first logarithm, so it's 2 log base 2 of 8. Now at the moment, forgetting about the 2 for the moment, because we'll look at 2 lots of it in a second, but just this log base 2 of 8, that means what power of 2 gives us the answer 8? And hopefully we know that that is actually 3, isn't it? Okay, so we can say x equals 3. 2 cubed equals 3. But we also have 2 lots of that. Okay, so not forgetting about the fact we have the 2 there, we've got 2 lots of x equals 3, or 2 lots of 3. And if we write that out, 2 times 3 equals 6. So our answer just there would be 6. Now let's have a look at our other one over here. We have log base 2 of 8 squared. Or in other words, what power of 2 is going to give us the answer to 8 squared, which we already know, or we've established, is 64. Not the nicest one there, but the power of 2 that gives us 64, and you're happy to check this, the answer is 6. We get x equals 6. So both of these give us the answer 6, and that's just going to show you obviously that they mean the same thing essentially. But again, this is just another way that we're able to manipulate the way that we write logs. So this number at the front can be taken as a power at the end. Okay, so we've moved that to just to being a power here with the 8. And obviously we could do that vice versa as well. If I had originally log base 2 of 8 squared, I could bring that 2 to the front. Okay, I could just put that at the front like we've done just there. Okay, so again, this is just another way that we're able to write logs, and this is important, as you're going to see on the final question that I'm going to show you, because the only time we can add and subtract logs is when they are written as a single logarithm. So having it written this first way that we have in the question is not very good to us if we're looking to do some calculations with it. We always want to bring that number back up to the power. So that's something very important to make sure that you've got there as well. Okay, but it's just another way of writing the logs. And if we were to kind of write it out, we could say something like this: a log base x of b can also be written as log base x of b to the power of a, and again vice versa. So there's another little rule that you're going to want to have written down, but hopefully just with a little bit of practice they'll sort of ingrain into your memory anyway. But this is our final little piece that I needed to show you. So we're going to have a look at a final question whereby we first have to change the logs and then apply some of the other rules that we've looked at, but hopefully this here shows you obviously how to go about that. Now, not forgetting here we need to get our final answer down, so our final answer instead would have been log base 2, not of 8 squared, but of 64, and there's our final answer. Okay, so let's highlight that off, and now we're going to have a look at putting this all together. Okay, so on to our next question. It says solve the equation 2 log base 5 of x, take away log base 5 of 3x equals 2. So slightly different, we don't have a log on the right hand side of the equation here, but we do have some other little bits to deal with. And again, just taking note, these logs do have the same base, so we can apply all of these little rules. But this log on the left is not a single logarithm, we have 2 log base 5 of x. So in order to do our subtraction rule here, we're going to have to use our little power rule, and we're going to have to move that 2 up to the x, or actually just our rearrangement of logs there, potentially bringing in our power rule later on. So in order to get that log on the left to become a single log, we can bring that 2 at the front up to the power with x. And again, thinking about that from some of our earlier videos, and do make sure you check those out first if any of these little bits with the logs are sort of going past you. So let's bring that 2 up. So that would become log base 5 of x squared rather than 2 log base 5 of x. Take away log base 5 of 3x, and that is equal to 2. Now they are both single logarithms with the same base, we can apply our subtraction rule like we did before, so we're going to divide those pieces. So we're going to have here log base 5 of x squared over the 3x, and again you can put that in brackets if you want, put that in a bracket, and that is equal to 2. Okay, so we're going to have to deal with this log now. As we only have the log on the one side, we can't just cancel it out from both sides. We're going to use our power rule here. I'm thinking about what this means, and it's a little bit more abstract than when we have just a numerical value here, but we have what power of 5 gives us the answer x squared over 3x. And it tells us here that that answer is 2. So in other words, 5 to the power of 2 is equal to this x squared over 3x. What power of 5 gives us that? And it tells us the power is 2. So that's 5 squared. So in other words, if we write that out, in order to remove our log here, we can write that x squared over 3x is equal to 5 squared. And obviously we don't need to write 5 squared there, we can actually remove that and write the answer as 25. So let's just get rid of that. Obviously you leave that for your working, but let's just turn that into 25, as we know 5 squared is 25. Right, so from here we can actually form our equation now. Oh wow, we've actually already formed our equation, but we can get it into a singular line. So the first thing we need to do is we need to remove this 3x. At the moment it's being divided by 3x. So let's multiply that over to the other side. And once we do that, let's bring this up here, we get x squared is equal, not quite drawing the 2 in there, we go, is equal to 75x. And there we go. Now obviously we have a quadratic as we have an x squared in there, so we want to get everything on the same side so it equals 0. So let's minus 75x to the other side. So we get x squared minus 75x equals 0. There we go. And just like with any quadratic, we need to factorise it. This quadratic here has no number at the end, so in order to factorise that, we're going to want to put it into a single bracket. So let's take out a factor of x. So we get x brackets x minus 75, and that equals 0. There we go. So we get our two solutions here. We've got two possible solutions. We've got the x on the outside, which gives us x equals 0, and we've got the bracket there, which gives us x equals positive 75. Now we've got two solutions, and when we've got two solutions, we definitely need to check these out. Now when we're looking at a log, we can't have log base of 0. Okay, we can't have log base of 0, because that means what power of whatever the base is, in this case 5, what power of 5 gives you the answer 0. And there is no number that you can put to a power of 5 or a power of anything to get the answer 0, just like you can't get a negative number. You can get very small numbers, fractions, you can get very large numbers, but you can't get negatives and zeros. So 0, this one here, if we think about that in terms of substituting it back into either of our logs here, if we were to put it into this log on the right, we would have log base 5 of 3 lots of 0, which would be 0. And that's not possible. Okay, we can't have that. So 0 here is not going to be included. We can have 75 though. If we were to put 75 in there, we'd get some very large numbers. Okay, we get 225 for the one on the right and 75 squared on the one on the left. So 75 would be fine. It would give us a positive whole number. So x equals 75 in this case is our final answer for that question. And there we go. Let's have a look at our next one. Okay, so that is the end of the video looking at logarithms. Obviously the next step, if you haven't already looked at it, is to go into the description and have a look at the video on exponentials. But there we go. Hopefully I will see you in another chapter revision video. Don't forget to like the video, don't forget to comment, don't forget to subscribe, and I'll see you for the next one.